Welcome to an insight video. So I'm going to show you what you can do inside of the new build of GCSTUDIO. So first of all, I'm going to start up GCSTUDIO, and lots of you have seen this before. So I go in, I've got a list of projects on the left here on the open recent. Didn't mean to do that, did I? Pick it force it now. Basically, like you've seen this before. There's files on the left, open file, open folder, create new project. I'm going to open a project in a minute. So you know that you can do this only when you see the word package manager at the top. I'll come on to that in later videos. Let's open up a project. The project I'm going to open up, and it has to be a project to use the new capabilities. We'll fix that later, but at the moment it has to be a project. And I'm going to open up a project called whatever it was called. It was called a project, and in there it has a file, and I've got a number of files. Let me just zoom in for you so that you can see that. It's got a file, and it's got a chip on it, option explicit, and I'm going to change this chip quite a bit in the next few minutes. But look, essentially, if I press function key F6, it compiles the program no different from than it's done before. So I have installed all the pieces that we need to install. I will explain all those pieces later on. What we're here to look at is new capability. On the left, we've always had these files. This is my project file. This is I've called it a GCB project, and in here I've got a number of source files. I've just compiled one of them. On the left, I can do searches. I've got my source control, which I use extensively, but I'm not using on this one. And then I've got run and debug. Let's have a look in there then. All of a sudden, we can see that what I am zoomed in on this screen, we can see there's a new thing here that says a GCBASIC, a debug, a GCB project, which is the project I'm working on. I don't have MPLAB installed. This is a standard installation, or a new installation, well, new, updated, and I've just taken that little green triangle, and it says on the left here, it's doing stuff. I'm going to have to zoom out a little bit so you can see it all. It says it's auto-detected things down here. Let me just open that up. It's create a build directory. There is a new build directory, and I will look at that. Look at what's happening on the screen. Bottom left, GCBASIC debug project. It's starting to do things. At the top here, it's got a blue cursor, and it says here, GCBASIC a debugger session started, stop on entry. All of a sudden, at the top right-hand side lot, we've got new icons appeared. We've got the classic debugger of reset target. Let me zoom in for you. Let me click on it, reset target, continue, step over, step into, step out, restart, or stop. Alongside these other icons that we had before, which is the old classic icons. What is different is we're in a debugger. So let's zoom out, function key F11, or you can press this little down key here. It takes you into the source code. On the left, you can see already we've got variables, CPU registers, program counters. It says here on the program counter where it is in the program, the registers, the top of the stack, status, etc. Program variables. It has already worked out that I've got some variables. Hardware. Let me minimize that because I'm trying to sort of show you quite a lot quite quickly. Hardware info, the type of chip it's selected, the RAM, etc. I've got watch statements. I've already got loaded latc and portc. It's great because they're in my project. I've got my call stack. I've got my breakpoints. So I can walk the code, function key F11 or press that little arrow down. It's going through my assembly that was generated by the compiler. And it's just walking through the setup, function key F11 I'm pressing. It sets the automatic pin direction of the triz. Oh, why don't we add that? to our watch statements. Right hand mouse button, add to watch. We've got a watch statement in here. F11. It's just set the trislot. Set the pin on. It just changed lat C. Cool. It's going to do a delay. Is it going to do a long delay? I think I've got it at microseconds so that we could walk the code here. It just turned the LED off. And it does do it. It does it for real. And now it's going to continue on. I'm pressing function key F11. I am walking the code inside of GC code, the code that was generated by GCBASIC. Let me stop that. Back into my demo code. I'm going to change that to port 1. I'm going to debug that project because I've changed the port, and we'll see what happens. So it's now assembled it. It's just creating the loaded files, and look at the top left, we can see a blue line progressing. Bottom left, we can see the debug project is running. It's programming the target in quotes. This is a simulator. Function key F11 will take you into the code. I am going to run the code to this line here by pressing function key F5. It's run the key to that particular stop. And it's already, you can see, trisc bit 1 that is now being set. Now, you can see the different bits have been set by this program. I've made change to the source code. I get it reflected almost instantly within the debugger. Our plan is to ship the simulator as standard. You'll be able to do this out of the box. So if I stop this, I go back to my source code. I'm going to change this to 16F1939. I'm going to debug it. It will recompile the source. It will change all the libraries as it always has done. It will then recompile it. It's auto-detected 16F1939, which is a legacy chip. It is a legacy chip, and we'll do the same in a moment for another chip. And in here we can see that we've got the same, essentially the same code, but trust me, the initialization is totally different. The frequency setup, etc., is different. And so I can run the code by pressing function key F5, and we'll see the variable C or lat C change as I increment through. The 0 and 1 in the top left there is turning on and off. Stop the code. Let's change that to a 10F200. Now I can't remember if C1 is real. I don't think it is. I think it's RA1. I am guessing. Why don't I not guess? Why don't I look in PIC info? I've opened up PIC info, just loading. I am just going to have a quick look in here for that chip because I don't remember the port numbers. Registers. It's GPIO. Okay. Run. I just recompiled it for a 10F. It's now bringing in the files, loading in the simulator, and it's now stopped on the entry. Now the code is extremely different because there is no org here, look. There is no interrupts on this particular chip. The init sys is extremely different. It sets up the pulls in the oscillator. It's completely different, okay? Automatic pin directions, and we can see out of scope. Look on the left, I've got no out of scope. C doesn't exist because my variable I need to watch in here is GPIO 0. Let me just F11 that, walk that code, and we can see that the LED would be flashing on and off if we had taken this code and programmed a real microcontroller. GCSTUDIO poor simulator.